early on. Welcome to All Tech Financing.
Good morning, classmates.
Good morning. Hello.
Hi. Good morning.
Hello.
How are you today?
What
was that? Oh, please don't
It's
make that.
long days. I grade papers 3:30 in the morning, Monday through Wednesday. So
Oh, you read what? Sorry.
I wake up and start grading papers at 3:30 in the morning. So before I go to work. So
Oh, you're like a teaching assistant or something?
no, I'm a university professor.
Ah, you are. Wow. Wow.
I'm an adjunct. I'm a security engineer normally during the day.
Wow. Excellent. Excellent.
What city are you in, Cheryl?
Michigan, Lansing.
Oh, okay.
Ah, you're up north, huh?
Yeah.
Michigan. I've been to Michigan only once for fishing trip.
Oh yeah, lots of fishing.
Yeah, good walleye fishing, yeah.
Yep.
I think that's what we did, walleye fishing.
Yeah.
I spent too much money on fishing, to be honest, on charter fishing. Yeah. However, so while we waiting for others to join, what is the biggest challenge for you right now with this exam? What area is the most challenging? People tend to focus on encryption and stuff like that, but there'll be so few questions and there'll be basic questions on encryption. I think the most complicated questions will be related to compliance. I think project management compliance, that would be more challenging. But I don't know. I mean, that's what I said. That's what I told you in the first session, that nobody knows everything, and you're expert in one area. Like you said, you're an engineer, so you know engineering side better than compliance, probably, right? So for
No,
you,
because I started out in privacy and compliance at a healthcare organization. So
okay, so
yeah,
so compliance is kind of okay. So
yeah, data loss prevention is where I specialize now.
no, but a lot of people who go into cybersecurity, they fancy themselves, oh, I'm such a hacker, I'm so technical, I can do this and that. And compliance is actually a challenge for them, because anything that has to do something with documentation, people hate it. People hate documentation. People hate reading documentation, writing documentation.
Right.
So
Yeah.
usually it's a big challenge, right?
Yeah,
So,
that's true.
so let's give one more minute and we'll start. We'll resume. Let me share with you. We're still covering crypto stuff, not the cryptocurrency, no, the crypto protocols and stuff. Yeah. And again, don't overread this because, yeah, you know, CSP is often described as ocean wide and paddle deep. In other words, it's 2-inch deep and 1 mile, 1,000 miles wide body of knowledge. So you need to know a little bit about everything, but not in depth. No. So do we still waiting for a couple guys? Oh my gosh! You know this Google Meet does this infinity windows. And by the way, it's not Christmas here. No, it's just my laundry day. So whatever I have clean, that's what I'm wearing. All right. So do you have pretty good understanding of PKI? We talked about last yesterday. So whenever so there's a if you look at the questions on the exam, the key that you need to first understand what the question is about. Is it about integrity or confidentiality, right? So if it's about confidentiality, the message will be encrypted with the public key of the recipient, right? And then only recipient supposed to have access to private key will be able to decrypt it. So that's confidentiality. Now, whenever you're dealing with integrity, you use your private key to encrypt it. And then the whole world can use your public key to verify your signature or the hash, right? The checksum. So there are two types of digests, keyed and non-keyed. Non-keyed message digests are made without secret key, and I call it message integrity control, right? Mix. Most
So,
of, go ahead.
I apologize. Can you repeat that again about confidentiality?
Oh yeah, sure, of course, yeah, it's an excellent question. So again, and it's all should be in the context of the exam. When you look at the exam questions, and there will be some indication the concern is confidentiality or integrity, one or the other, right? So if the concern, if your primary objective is confidentiality and you're sending a message to somebody, you use public key of the recipient to encrypt it. And then only recipient who has access to the private key, his or her private key, they will be able to decrypt it, right?
Correct.
Now with integrity, you're not concerned about confidentiality. You want the whole world to know that it's your message. You signed it. And that's why you use your private key, which will be, people will be able to use your public key to ascertain it. And I don't know if you remember, I showed you Open PGP directory. And
Yeah.
a lot of, and most of the time, you're not going to be using Open PGP most of the time because it will be in the business context, and your business will have an internal directory. Typically, it's stored in Active Directory or some other kind of LDAP directory. That's where the keys will be stored, and people will be able to pull out your public key and verify your message that you did sign it with your private key.
Does it matter if it's asymmetric and symmetric? So I would think like integrity would be asymmetric with me using my private key.
Everything we're talking about now is asymmetric.
Oh, confidential and private is asymmetric?
Yes. So with symmetric, everything is, we'll talk about this a little bit later, about key management issues. Historically, it's been always a problem how to distribute the keys, right? With Julius Caesar or with Enigma or the Germans, during the World War II or Japanese. I mean, that's always been the issue, the distribution of the key. That's why asymmetric system is such a miracle. So,
Oh, okay.
yeah, yeah. So message authentication code, MAC, also known as cryptographic checksum, is a small block of data generated using a secret key and then appended to the message. And the same, most of vendors like Microsoft, Red Hat, they do the same. They have private keys, they sign their software with private keys, and then your operating system, when you download and install the software, it's actually
Black screen.
automatically blank screen. Okay.
Oh,
actually-
wait, now it's back.
Okay, it's actually a good time for me to stop sharing and then share again, and I will show you cryptographic function in action. So, so on Windows, you have a search util. Do you see a black screen, the console?
Yes.
Yes.
So for example, now choose random file, doesn't matter which one. So I type cert util, and you can do it on your Windows box. And you type hash file, and let's choose Rimacom, whatever. Oh gosh, let me remove this one. Yeah, Rimacom. Let's say we choose MD5 algorithm. So you see it produces hash. MD5 hash, that's what it is, right? And we could do the same with SHA-256. Oops. I need to remove the MD5. SHA-256, yeah. So you have a hash here, right? Now, if I open the content of the file and I echo it to the hash will be, of course, different, right? You understand that? So whatever the content you feed, you can experiment with that and just to gain better understanding of this. All right, so let's go back to our slides. All right. So checksum or digest, this used synonymously. So in other words, if you see a question about digest or checksum, it's all the same, right? And so we just discussed this. So the private key would use to generate digest, then public key would be used to verify the digest.
Went blank again.
Blank again. I don't know why. So I'll stop sharing and I'll share again. Maybe I'll need to reboot my laptop. Maybe that's what it is. You know, with Windows, rebooting solves all the problems. So do you see digital signature slide?
Yes.
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 Yeah. Oops, what happened? Oh, it died. It just died. Give me 1 minute. I will reboot my laptop because it's Windows. So I'll be right back. Sorry. Okay, just a couple more clicks. Tells me to click that and this. Yeah. All right. Sorry about this. Opening the slides. While opening the slides, if you have any questions, feel free to speak up now. And here on the slide 89. Okay. Yeah. All right. You should be looking now at the key management practices slide, right?
Yeah.
So, and again, everything we discuss, you should consider in the context of the exam questions, right? So let's take a quick look again at digital signatures, just to make sure you understand it, because there definitely will be at least 2-3 questions on the exam. Not too many, but yeah, you need to. Do you remember confidentiality or integrity? That's what you're looking at. Those are your clues. You look at the question. If it's talking about confidentiality, then recipient's public key is used for encryption. Now, if you're talking about integrity, your private key is used to generate the digest or signature. You remember, digest to signature is the same. It's synonymous in this context. Okay. All right. So key management has historically been a big challenge, um, because imagine you're a CIA, you have agents in Russia or China. How would you transmit key to them, right? And historically, people would tell them, "Oh, look, it's this book, chapter 5, page 20, fifth line from the bottom or whatever. Use that as the key." And as funny as it sounds, that's how the keys were used to be distributed for a long time. And of course, public key infrastructure solves this issue with the keys. So key recovery is an important aspect also, just remember, for the exam purposes.
Can you explain key recovery?
Well, it is what it sounds like, right? So if you lose your key, what's going to happen? And what is key, by the way? Key in this case, 90% of the time, it's just a password. It's your password is what a key is. And if you forget your password, then yeah, you lose access to your data. So imagine you have a secure bucket, S3 bucket in AWS, and you forget your key or you lose your key. I mean, there's an option, AWS gives you option to use their key management system, or you can use your own key management system. Imagine you choose to use your own key management system and your laptop is stolen and you lose the key, you lost your data. You don't have access. So key recovery and some kind of backup mechanism, it's provisions like escrow service or other services when your key is stored with a third party, possibly. So if you trust AWS, they will store it for you. And then once you prove that you're an account holder, they will give it to you. And then you can recover your data. But imagine you choose not to use AWS service and your laptop is stolen, and that's the only place where you had your key. And key doesn't have to be password, obviously. It can be any long string. Like a lot of crypto systems allow you to use file as a key. And imagine your file contains um, Shakespeare chapter 1, Macbeth, whatever. The entire Macbeth chapter 1 will be the key. That's the key. And it's a very long password, right? hypothetically, I mean, it's not very practical because it will take a long time to encrypt. The longer the key, the longer the encryption, of course. But yeah, so when you see key, think of password. It doesn't always have to be password, could be image, could be anything, could be a fingerprint. Key could be any of those, but typically it's a password in most of cases. So when you read this slide and says key management practices, you can dumb it down. You can say, okay, password management practices. But the thing is, key is not limited to passwords. It could be many other things. But for most people, it's just a password. Well, in Windows, if you use BitLocker and you have a smart card reader, then your smart card would be the keys. It would contain the key storage. And TPM, Trusted Platform Module, TPM, is one of the key functionalities is key storage, key generation. So, and it's done transparent to you. You just log in into Windows and it will decrypt your whole drive encryption. So if your whole drive is encrypted on Windows, your TPM would be storing the key, would generate the key, and all you do is just you type your password and it will unlock it. So, and here's if you look at this slide, line 3 from the top, trusted, tamper-proof hardware security modules. And if you remember a couple of days ago, we talked about TPM, and one of the features was tamper-proof, right? So it's one of the features provided by TPM. Passphrase protected smart cards is another example. Key wrapping session keys using long-term storage keys. And KEK is a key encryption key, so not a key for encrypting your keys. It sounds funny, ridiculous, but it is what it is. So in some extreme cases, splitting cipher keys and storing physically separate storage location may be necessary. I mean, I don't know if it's probably in high impact environments like NSA or CIA. I don't know, maybe they do that. About 10 years ago, no, more than 10 years ago, I went to West Virginia, and I don't remember the name of the town, but that's where Treasury Department has its CA server, Certificate Authority server, and I did auditing, and two individuals had to come with two different keys to open the cage. So the server was inside of a metal cage, and two different individuals had to come with two different keys, physical keys, to open the cage, demonstrate to me that it's all secure and so on. So in some cases, yeah, some extreme measures like this can be applied.
I'd say an example of key escrow in my experience would be some people I was working for were just integrating BitLocker, right? And installing it on the organization's laptops, and they didn't collect the decryption keys or deploy an HSM. So then they had to go back to Dell, who was holding said BitLocker keys for the in escrow. So
with HSM, yeah, it's so HSM is hardware security modules. They've been around for the last, I don't know, I've seen them since late 90s. Yeah, a lot of, and right now hardware security modules are even more ubiquitous because any Internet of Things device, they just don't have enough CPU cycles. They don't have enough memory and CPU capacity to generate the keys or manage keys. And so the hardware security modules are used typically. And they're so cheap nowadays. It's an economy of scale. So anyways, weird slide. Yeah, let's go to the next slide. Yeah, that's an excellent example. Yeah, when vendor could be used as escrow service. Yeah. And then once you prove that you are who you are, then you will have access to the keys. And most of cloud vendors, they have this service. They It's called key management service or something similar. I think AWS, that's what they call it, KMS, key management service. And there's option, explicit option. You can choose either you allow them to manage your keys for you, or you store your keys in your own devices. Which depends, yeah. I mean, depends on your risk profile. One or the other may be preferred. So algorithm protocol governance. If you work for the federal government, it's so easy for you because you just go by the FIPS standard 140 dash whatever the current one is. I think it's 4. And you have to use those. You cannot use any others. Obviously, if you do international commerce, if you work internationally, especially if you're dealing with some countries that on restricted list, you remember the Wassenaar agreement we talked about? Wassenaar agreement limits the export of crypto and dual use technologies. So, of course, that would affect what kind of encryption you can use. But otherwise, in the United States, most of you would be using FIPS 140 compliant encryption. So, all right. So now we're going to talk about methods of cryptanalytic attacks. We used to joke that the most effective cryptanalytic attack is a garden hose attack, right? Anybody heard of that? Meaning physical attack. You beat somebody with garden hose until they give you the key. So your theory must be able to describe defenses against common cryptanalytic attacks. So, strictly speaking, and especially Cheryl can educate us about this. She's a professor at university. So it's analytical study of cryptographic systems, algorithms. So cryptanalysis, it's a business discipline, and it's concerned with the study of cryptographic systems, algorithms, and their operational use to gain greater understanding of their strengths, weaknesses, and characteristics. Cryptanalysis can be done in many ways. As I mentioned, some people think one of the most effective ways is garden hose cryptanalysis. And obviously, garden hose cryptanalysis would work if the key is a simple password. Nowadays, in modern environments, it's not password anymore. It could be physical hardware token, it could be RSA device, could be whatever. So we will go over most common cryptanalysis techniques, and don't try to memorize them all by heart. Just the key, and I keep on saying this, when you look at the question on the exam, oftentimes you just need to know whether it's plausible or not, whether it's whatever they're asking, whatever the multiple choice is, does it sound like a real one, like a valid option, or does it sound like BS? So that should be your focus. And also, I like telling story. It's a real story. It happened in 80s, I think, in Moscow. So imagine United States Embassy in Moscow. Maybe it was even 70s, because they ordered typewriters. So they needed typewriters to type whatever they letters and stuff. And so they ordered typewriters from the United States for the US Embassy in Moscow in Russia. And somehow they were compromised when in transit. And the way they were compromised, so the Russians installed a transmitting device would transmit the sound of each key that was being typed. So each key, turns out, has a unique sound. It's unique enough to distinguish. And Russians were able to transmit those sounds of typing different keys to their listening post. And then they analyzed, and because each key had a unique sound, slightly unique, they were able to actually read all the messages. Imagine that. So that was one of the examples of rudimentary cryptanalysis, right? So it's not mentioned here, but do remember for the exam that social engineering is one of the, it's very effective and it's a valid type of attack, right? So remember that. So ciphertext only, obviously that means you only have ciphertext, you have encrypted text, and you have to work with this. Non-plain text, which is probably the easiest way to do attacks when you know what the plain text is and you know what the output is, crypto, then it could be analyzed and sometimes successfully decrypted, right? So it's related to frequency analysis, is defined as knowing linguistic patterns of letters and words, frequency in certain alphabets and languages. So one of the most amazing demonstrations of this type of attack was done by a Polish mathematician, Marin Nieszewski, in 1932, with the assistance of several colleagues. He reconstructed the entire early Enigma crypto system, which is amazing. So, non-plain text, chosen plain text, it's related to non-plain text. When cryptanalyst is able to choose the quantity of plain text and then obtain the corresponding encrypted text. So, chosen ciphertext, similar. When you choose the ciphertext, you have the ability to choose ciphertext and see if you can decrypt it. Linear cryptanalysis is known as plain text attack, using a linear approximation strategy to guess at the behavior of the block cipher. Differential cryptanalysis begins with a chosen plain text analysis. An attacker makes minor changes to the chosen plain text to see if there are corresponding minor changes in the resulting ciphertext. If some of you may remember, we talked about two properties of a good, strong encryption algorithm: is avalanching and deterministic, right? So deterministic meaning that for hash function, every time you provide input, the output will be the same. It's not going to change, even if you run this 1,000 times. Now, avalanching property is when you introduce slight change, just one character out of 10,000 characters, and resulting difference will be very significant. So that's the avalanching property. All right. So brute force attacks, and it's very easy to understand. Think of imagine your travel suitcase with a lock that has those 4 dialing rings, right, with the numbers. How long would it take you to imagine you've forgotten your PIN code on your this dialing rings? How long would it take you to determine the correct one? I mean, even if you try every single possible combination, still be probably what, 20 minutes, no more. But yeah, you would probably start with year 2000 and work downwards, right? Because most of people use their child's birthday or their loved one birthday, like 2007 or 1997, right? So brute force attack, yeah, when every single combination is being tried, and depending on the key size, it may take, as you can see in this table, it may take, pardon me, it may take years to break it if the key is long enough, right? Any questions? So I just hear some sounds, and I'm not sure if anybody's trying to ask a question, or if you just forgot to mute your microphone. So, and again, there will be about 20 different types of attacks. You just need to be able to recognize them as valid ones. So when you see on the exam, there'll be multiple choice questions, and you will see, let's say, 4 of these, right? And one of those options will not be a valid one. And then you need to be able to recognize the wrong one, the fake one, as the fake one. So pass the hash. It is what it sounds like. When you have access to hashes, you can inject them into DLL processes, you can pass them to applications, and you can get authenticated using those hash credentials if you have them. That's the idea. Kerberos exploitation. So Kerberos was originally developed by the Massachusetts MIT. It became very popular network authentication protocol. Microsoft embraced it. It was used. It's still being used. And so it's an example of single sign-on. So successful implementation and operation of Kerberos requires overall security of the environment, synchronization of clocks. It's very important that the time is being synchronized, enforcing limited time lifetimes for the authentication for the Kerberos tickets. So key distribution center must be physically secured. Typically, it's Active Directory, the same server. So KDC must be isolated on the network. So all those factors, they may affect security of the Kerberos, and each of these aspects could be exploited. But just remember that Kerberos exploitation is one of those exploitations that belong to the category of implementation and algorithm attacks. So man in the middle, MITM, or machine in the middle, or person in the middle. They look to insert a third hostile party into the communication path between the sender and the recipient. Once there, the malicious party will find ways to copy, intercept communications, payloads, hashes, keys, and other metadata. This is a very broad category of attacks, but the idea is, yeah, just what it sounds like. It's man in the middle. Somebody is able to intercept the traffic and replay it or manipulate it. So side channel attacks are more sophisticated. They're passive attacks that rely on a physical attribute of the implementation, power distribution, emanations. Also, if you have access to the same system and you can read the memory of the system, then of course you can stage a side channel attack.
Can you explain past the hash again?
Okay, sure, yeah. So let's start with the word hash. Yeah, hash brownies, right? So you remember that hash is one-way function, right? So I showed you today on the command line Windows when I did a hash of a file, and it produced depending on the algorithm, MD5 or SHA-256, it produces a fixed length output, right?
Yes.
And so in a lot of authentication systems, like nowadays, if you create web application, in the past, web applications actually stored clear text passwords. A lot of time, yes, usually. And that's a bad idea. So nowadays, modern applications, when they provision a user account, they don't store the clear text password, they store a hash of a password. So imagine, for example, on cell phones, you have those dating applications like Tinder and stuff. They store hashes of the passwords in a light SQL database. And imagine somebody stole your phone and they know your passcode, or they know whatever the thing you draw on the screen, they observed it and they stole your phone. And if they have access to this light SQL database, they get all those hashes and they will get password for your Tinder account or Bumble account or whatever you use. And so they could use the hash to authenticate to application. In some cases, it's not always possible. Depends how the application is implemented. So imagine your web application does not accept hash. It only accepts the clear text password, and then it converts it to hash and then does the authentication. Then it wouldn't work. It failed. But past the hash is when applications, they actually accept the actual hash. And it was so for many years with Windows systems, with NTLM. I don't think it works nowadays. I think Microsoft fixed it. But 20 years ago, it was exactly that's just as I described right now. You could pass the hash instead of the password, and you would be able to authenticate to SQL database or some other Windows applications.
Okay, thank you.
I don't know if I made it clear or even more complicated. It's so nowadays I don't think there are too many applications that would be vulnerable to this. It's more of a historical vulnerability. I don't think nowadays, because imagine your application, so there's some kind of login screen, right? You type your username and password, and then application takes the password, converts it to the hash and compares with the hash in their database. And if it matches, it authenticates you. So if instead of typing your password, if you send hash directly, then most of modern applications will just say, okay, it doesn't match, doesn't work. So, all right. So fault analysis was when, and it's related to fuzzing attacks, when you provide input to application or to system that forces it to go into error state, and then you see how it behaves, and see if it discloses any information and so on. So probing, so attack to watch circuitry surrounding cryptographic module in hope that other components of architecture will disclose information. Replay, meant to disrupt and damage processing by resending of repeated files or input to the host. So replay is if someone, so it's related to man in the middle, right? Someone has to intercept the messages. So if someone intercepted the whole authentication transaction with all the packets and they're able to replay it, then it's in some cases, depending on application implementation, it may actually work, may allow malicious users to authenticate and gain access to data. So algebraic, it is what it sounds like. It's a class of attacks that rely on the math structure. It's mathematics of certain block ciphers. So that's, I would say it's very sophisticated, definitely about me to understand. I did take calculus in college. Somehow I got A. I don't know, it was a miracle. So rainbow tables. A lot of you probably know what rainbow table is. They used to be very popular. You could download them. A lot of people were downloading terabytes of those rainbow tables. So what it is, it's a pre-computed database of hashes. So there used to be a rainbow table for MySQL, for example, or for some other databases or applications, popular databases, popular applications. And so you remember how brute force works. Imagine you type, we talked about suitcase, travel suitcase, when you have those 4 dialing rings, the wheels. So with rainbow table, instead of recomputing hashes for every combination of password, you do simply look up on the table. It's already pre-computed for you. It's already there. So that's what rainbow table is. It's a database of pre-computed hashes. So there's a hash for word password. There's a hash for word Jesus. I love Jesus. All of those hashes are already there, and you don't need to recompute them. You just look them up. And that's the beauty of it. And of course, it's very limited because I think the maximum rainbow tables that existed, they were limited by 12 characters, I think. So let's see something. Do we have a message question? Oh, let's see. Can you please send us the definition for brute force attack?
Yeah, because it's tricky when they question about it. They don't just, say that it can be like different options when you're trying to break something. It's more complicated than that.
I don't know. I mean, let's see. What do we have here? So brute force attack.
I do understand the behind, but it's not as simple as I understand it, as far as I know. Because it's not just, trying all combinations. It's more than that. If I understand it well.
No, it is actually trying all combinations. So, okay, imagine Bank of America website. You come to Bank of America website, and there's a login page. It says, what's your username? What's your password? Let's say, imagine you know the username because you observed it. You were standing, you went to those internet cafe, and you saw another person typing username, you remember it, right? So the username is Mary Jones, for example. So you know the username, but you don't know the password. You don't know the password, right? And so you would, for example, the utility is called, for example, Hydra. Hydra used to be utility for free. You could download it, use it on your laptop. Hydra. And you would define the range. You would say, okay, start from 8 characters. It should be 8 characters, no less. And it should be English alphabet only, or you could say Russian alphabet or Hebrew alphabet. And this utility would attempt to log into this application using every single possible password in the range of 8 characters. So that's what it is. That's brute force attack.
Yeah.
And that's why look at this slide. It says the one on the right hand side. So there's explanation. So cracking 128-bit AES code. So it takes about 1,000 floating points ops to check a combination, right? To one combination. So in other words, it's about 10 attempts per year for a supercomputer.
Okay. So there is no hashing involved, right? It's only like a clear text, right? There is no something with hashing or, do a comprehension for a list with hashes, or it can be possible because that's a rainbow table, right? Because I saw some question which is dealing also with combining hash rank table, and it was like correct. So yes, I don't remember the specific question, but That's only my concern about it. I understand it
No,
basically.
no, no.
Yeah,
It's a very good point. Very good point. You are correct. You are
'cause it's
correct.
tricky.
So with brute force attacks, you typically dealing with the interface, like
Yeah.
as I described, Bank of
Mhm.
America website, for example.
Yeah.
So you're not concerned whether the application does hash conversion or it doesn't do
Mhm.
hash conversion. You're not concerned
Mhm.
with that. You're just hammering it with all
Trying
possible
to, yeah.
combinations, right? Now
Mhm.
with a rainbow, it's a different type of attack. Imagine,
Mhm.
imagine your friend works at Bank of America, and your friend used a USB stick and copied the whole database of passwords, the
Mhm.
USB stick. But the problem is it's not clear text, it hashes.
Yeah.
And so you cannot use it because it's hash. It's hash.
Mhm.
It's not a clear password. And so you take it home and you launch a rainbow attack, rainbow table attack, trying to crack those hashes, convert hashes
Yeah.
into clear text password. So no, it's a very good question. It's a very clear distinction there. Yes.
I think that, Alex, maybe if we'll see, or if you can filter when we do the practice question with brute force, maybe we can see some kind of, manipulations to that, which will be, maybe clear what I was looking, because I don't know how exactly to define it, but I know, as I said it at the beginning, that it's sometimes in questions it's more complicated than, choosing an option which says do the same thing again and again until breaking it. So maybe I'll
So
see.
no, it's a good point. It's a good point. So the distinction is with brute force attack, you're sitting somewhere. You can be sitting in Nigeria or in Russia, and the application can be in Washington, D.C. You don't have access to the internal database of those passwords. That's the key distinction. You only have access to the external interface of that application. That's when you launch brute force attack, right? Or maybe it's a desktop application and maybe it's installed on your laptop and you doing brute force attack. Now, with the rainbow table attack, you actually have access to the database of hashes.
Mm,
And that's when
mhm.
your problem is you have the hashes, but you don't have clear text passwords. And so you need to convert them. So because pass the hash doesn't work with most of applications. Most modern applications, they are not vulnerable to pass the hash. They're not.
Yeah, they're limited.
So anyways, excellent, excellent.
Thank you.
Good question. Yeah, good question.
Thank you very much.
Sure. All right, where we left off. So we did replay. So with replay, yeah, the key is you're able to intercept it. In other words, you have access to either device or the network. So we talked about rainbow table, the last one. So frequency analysis. When frequency analysis, typically you would most of average malicious attackers would not be able to do frequency analysis. Requires a lot of sophistication because you remember it needs to analyze the actual linguistic patterns. For example, um, you know that in English, most if you see encrypted text, and you see three letter combination, then you know most likely it's the word the, right? And that's the frequency analysis. It focuses on analyzing the proximity of one letter to another and most commonly used words in the language, target language, right? So the birthday attack, the birthday paradox, it says that if you got a group of 23 or more people, then two or more people in the group will probably share the same birthday date, and that's a likelihood of 50%, supposedly. So, and the attacks are based on that when you're trying to use the birthday patterns to guess the password or to guess the key. All right, so let's. Actually, I don't need to drink water. I'm sorry. Let's take a 6 minutes break, please. I need to drink somewhere and don't have any here. Mm. All right, guys. Did I miss anything? Any questions? Anything? All right. So check your understanding.
Screen's blank, Alex.
Oh. Okay. Okay. Thank you. Let me stop sharing. Share again. That usually fixes the problem.
I think that when you touch it, after it's white, then it came back because that's what happened before you share it.
This is the first time in my life I'm using Google Meet, and I think maybe it's related to Google Meet problem. I don't know. It amazes me because this laptop I just got it recently, and it has 16 gigabytes of RAM. It has 8 cores, so it's supposed to be powerful, right? Nothing works better. Same problems, same issues like my old laptop. So I have second laptop, and anyways, do you see the screen now? It says check your understanding which of these attacks are typically the slowest to execute for an attacker. Do you see the screen?
Yes.
Okay, excellent.
Yes.
Thank you. Thank you for your feedback. So, and you remember, well, and it's a tricky question, but in general, you need to remember that a brute force attack involves testing all permutations of a key in turn, right? So you start with one. You remember a lot of tools, they allow you to limit it. You configure the tool like Hydra, you configure it and say, okay, minimum 8 characters. But how do you know? Maybe the password is 12 characters, right? Like nowadays, a lot of passwords are 12 characters. And to run all combinations of 12 characters, that's a long time. So let us go back just for a moment and you'll get the right answer. So look at this slide again. Look at the right-hand side. So triple dash or 56-bit encryption. Using modern laptops, modern computers, you'd be able to crack it in 5 minutes, right? 128-bit, and it already requires so much more time, right? And 256-bit, using your commodity laptop or your commodity desktop, you probably will never be able to crack it. And so the right answer is B, the brute force attack, right? So, okay, do not, so you will not be tested in depth on any of this, but you need to kind of remember and recognize them. You remember on the exam, you will see question, you need to be able to recognize what is valid, what is plausible, what's not plausible, what's BS, right? So man in the middle is plausible, Kerberos exploitation is plausible, side channel is plausible, it's correct. Pass the hash, yes, does exist. Fault analysis does exist. Probing does exist. Replay does exist. Algebraic, rainbow table, frequency analysis, birthday attack, they all exist. That's what you need to remember. So factoring attack is aimed at the RSA algorithm specifically because that algorithm uses the product of large prime numbers to generate the public and private keys. And so this attack attempts to find the private key to solving the factoring of these public keys. If you're more interested, read about Diffie-Hellman's discovery and stuff, but it's very sophisticated stuff. So dictionary attack is used most against password files if a copy of the password file can be obtained by attacker. So it's not the rainbow. Rainbow is much easier, but imagine if any of you used Linux or Unix, and imagine you somehow you got the Etsy password file with hashes, and then you can launch dictionary attack, which will try all the dictionary passwords against it. Maybe say it again, please. Somebody said something. So dictionary attack is using a dictionary, and dictionary in this case, it's ASCII text file. It's a huge file, can be 1 megabyte, could be 1 gigabyte, but basically contains all the possible combinations of passwords, and you use that to test. Attacking the random number generator. The attack has been successful against certain cryptographic implementations. So if the random number generator used by crypto system is too predictable, it may give attackers the ability to guess or predict the random number that are critical for setting up initialization vectors in cryptography system. So historically, Linux, Windows only had pseudo-random. In other words, it's not true random number generator, pseudo-random. But with TPM version 3 and later implements the true random number generator, which is kind of amazing for me. No, I'm saying amazing because I remember, so we immigrated to the United States from France, and we went to the first state was North Carolina, and I went to school there. It was Campbell University near Raleigh. And in one of the classes I've taken, I was a C programming class, yeah. And my instructor was IBM dude. And he's in the first class, he's asking, who believes in true randomness? And I'm like, yeah, I believe. He's like, he ridiculed me. He was like, presented me like complete fool because, oh, there's no true randomness. It doesn't exist. It's all pseudo random. And I felt like so bad. It was like, yeah. But, disculpa. Sorry. But recently I was actually interested in, I asked Gemini, the artificial intelligence platform, and I asked, is TPM using true randomness or pseudo-random? And I was pretty sure it would be pseudo-random. And guess what? Gemini says no. TPM, Trusted Platform Module, actually implements true random number generator because it's relying on some environmental conditions, some temperature, electricity, whatever it is. I'm not sure, but yeah. It's all right. Temporary files. Most crypto systems need to use temporary files to storage in storage to perform their calculations. So if these files or storage locations used in architectures are not deleted or overwritten securely, they may possibly be accessed and compromised and lead to attacker to conduct successful cryptanalysis. Yeah. There's actually well-publicized vulnerability in Windows related to that, but I think they fixed it. So here's a little entertainment for you. There was a man, you can Google his name, Harold T. Martin. He was working for NSA, and he was so bored. He lived, I think, in somewhere in Maryland. Yeah, obviously works for NSA. Obviously, he would have to release someone in Maryland somewhere. So in the basement of his house, he created a playground, digital playground. He brought from NSA, from his place of work, a lot of tools that NSA developed, the exploitation tools for Cisco, for Windows, all those zero-day vulnerabilities and stuff. He brought them home and he was experimenting with them, playing with them. So his name again, Harold T. Martin. And guess what? One problem, he used Kaspersky antivirus. And you know how antivirus works, right? Well, they're signature-based and heuristic-based analysis, but all of them implement the signature-based, right? Signature, in other words, this utility creates a hash of a file and compares against the hashes of the known files. And so Kaspersky, being a Russian company closely associated with the Russian government, was looking for files associated with intelligence services. And so it ran the scan of his systems, Hierarchy Martin's, his computers, and of course it identified, based on signatures, known files that Russians believed were associated with NSA or CIA or so on. And of course, so they stole all those files and they published them. You remember those shadow brokers? If you Google shadow brokers, that's the story. And so, and long story short, we don't want to go too much into history, but that led to eternal blue attacks, right? And Microsoft quickly released patches because they worked with NSA. They obviously knew what needs to be fixed quickly. And most people who in the United States were not affected because they had, most people, businesses here have fully licensed versions of Windows. But people around the world in developing countries who did not have a licensed version of Windows, they were affected badly. They were exploited. And most common type of attack was ransomware. And guess what? Disney was affected. Their new version of Pirates of the Caribbean, the movie, it was encrypted, and supposedly, reportedly, Disney paid a ransom to have the Pirates of Caribbean decrypted and made available to them again. Anyways, so here's a couple of strategies. So we need to denial, detection, containment, and so denial means negate the effects of ransom attacks. Denial of blackmail attempts is best done if you have full backup of your stuff and it's not on the same location, obviously. All right. Yeah, you want to contain those attacks, detect them, and response and recover. So here's a good case study. So Stuxnet, sorry, supposedly developed by Israelis, never confirmed, never denied. Some say it was developed by the US and Israel together. It was designed specifically to cripple Siemens cooling systems that Iranians used in their nuclear facilities, uranium enrichment facilities. So, so we have a couple of questions here. Do we need to discuss in more detail this case study, or are you familiar with Stuxnet?
No, not familiar with it.
So in 2010, what's unique, it was one of the first examples of very sophisticated malware that was designed specifically to cripple Siemens cooling systems. Obviously, because it was intelligence services operations, we don't know too much factual information. But supposedly, it was introduced to you via USB thumb drive. Somebody intentionally or by accident plugged the USB drive, it executed, and it propagated itself on the network. And what it did, it identified slowly over a course of many months, it identified Siemens industrial control systems. And then it began to manipulate its operation. It arbitrarily, seemingly increase the velocity and the speed of the cooling systems, the fans and so on, and then it would slow down, then it would increase again, it slowed down. Eventually it crippled the whole cooling system. And because of the facility needed this reliable cooling system, basically the whole program was sabotaged. So, so here's a couple of questions. We can discuss, or we can move on, whatever you prefer. So Stuxnet demonstrated deep understanding of engineering processes, right? In other words, people who designed it, imagine it's a secret facility and you can only guess what's being used there, right? So you can use some circumstantial information. How did they know it's Siemens? Well, apparently somehow they knew that Siemens has trade relationships with Iran, and they knew that Siemens systems can only be used for the specific purposes, right? So it's very interesting. It's fundamental concepts of security models were also part of this intelligence program, because they had to understand the entire environment, how the security is implemented, and so on. So, and Stuxnet binary itself, the whole application, well, it wasn't single file, it was multiple files. It implemented a lot of encryption and crypto to obfuscate, to hide it from detection. So it's a dual role of cryptography in both securing communication, in this case, complicating the analysis of security researchers. So in other words, when it was discovered, it was not trivial to analyze it because it was applying cryptographic techniques and the binary itself were encrypted. And so it's very difficult to analyze it, what it was designed to do, right? All right. Let's do a couple more slides and then we'll switch to review questions today. So this is an important acronym. Try to remember it. Crime Prevention Through Environmental Design, CPTED. So information security practice influences and is, well, influenced by also a wide variety of other professional disciplines. It's crisscrosses. So physical security is essential in many cases. Even though now with cloud deployments, physical security becomes less important, it's still a factor. So physical security is essential to ensuring that information processing activities are able to be performed and that information is not lost or destroyed through deliberate or accidental physical events, and that the people who do the work are physically safe. So one of the design approaches to this problem is crime prevention through environmental design. So it approaches the challenge of creating safer workspaces through passive design elements. All right. Let's take a moment, just read this diagram. So those are some of the key elements. So crime prevention through environmental design provides direction to solve the challenges of crime with organizational, mechanical, and natural design methods, right? So it involves multiple aspects need to be considered, such as people, technology, hardware, and the natural design, like architectural circulation flow, by directing the flow of people using passive techniques to signal who should and should not be in the space and providing visibility to otherwise hidden spaces. So the likelihood that someone will commit a crime in that area decreases. So let's go back again. So there's territoriality, surveillance, legitimate activity support, access control, target hardening. Those are some of the key elements. All right. So CPTED is commonly associated with the broken windows concept, that where neglect is present. If something is neglected, physical security, the crime will increase, right? Conversely, well-maintained orderly spaces, they decrease the likelihood of bad activity. So this notion of perceived ownership provides a passive deterrent by indicating that the owners are paying attention to the property and will detect any out of normal actions. So territoriality suggests that there is a distinction between public and private spaces. So in a building, such characteristics as doors and locks, signage, staff uniforms, placement of reception, guard desks, they all possibly influence the behavior of people in space. They condition their mind, they condition their behavior. So applying the logic of CPTED to building design suggests a number of ways to shape the behavior of people and condition their behavior, right? So landscape design, for example, could be used turning facility into a fortress. Elements such as water and vegetation. Obviously, if there's a small pond in front of the building, then nobody's gonna. Well, it's very unlikely that criminals would go through the pond, through the water. That would limit the access, the ingress space, right? So a guard with a switch that opens the door can be problematic, since the guard may be subject to intimidation, social engineering. But contact alarms can also signal that the door is blocked, open. So, so let's see. So here's some other aspects. Availability, building codes may affect. A lot of things like turnstile, man traps, key locks, laminated glass, they all may affect. They all would condition behavior of people and minimize the likelihood of any mischievous behavior. All right, let's see where we are. Yeah. All right. So building codes and stuff, availability would ensure a minimum level of safety. Compliance is crucial. A lot of building codes would for data centers would be specifically data codes for building for data centers, different story. Let's go back. All right, let's stop here and let's go to the review questions. Let me stop sharing for a moment and I will open the questions. And we stopped where we stopped. Then question 48. Yeah. I think we did cover 48. We were discussing about how many questions, how many steps there. Oh no, we actually did cover. I remember now. We covered 50. Do you want to go over these questions again, or we just skip to where we left? Because I think you remember we talked about threat X is not valid methodology. You remember?
Yes.
Yeah, I do remember that. I don't remember exactly where we left off. Please remind me. Training. I think it was like
57.
57.
I think that was the last question.
Okay. Okay. Well, let's review it again. Just refresh it as a refresher. I don't remember, to be honest, this question, but if you believe. So, which of the following activities? No, I don't think we looked at this one. 57, definitely not. Maybe 56. Yeah, 56. I remember we were discussing that. Why? Because email advisories, online IT security, daily news websites, they don't really qualify as programs, right? As like a training, educational programs. We discussed that. Yeah, that's what I remember.
So that'll be a
Yeah,
wording.
that was a
Yeah, the alpha would be the correct answer here because we discussed it. If this list did not include the daily news websites and email advisory, it would qualify as training programs, right? Educational programs. But the news websites, they don't really qualify as such. So that was the rationale. So question 57. That's a long question, huh? Ensures cybersecurity team at a multinational firm evaluating effectiveness of their company security education, training, and awareness. This current rapidly changing security environment.
I think C.
Yeah, because so if you do by exclusion, updating company IT infrastructure, that wouldn't do anything, right? Annual completion of specific set online courses, no, it's not. So yeah, it's C, Charlie. Yeah. All right. Domain 2. All right. Oh yeah. So addresses organization's ability to use its own information readily and confidently, reliably and confidently, reliably and confidently, free from interference by others.
B.
I'm thinking A or B.
Well, the correct answer is A, alpha, but why? Why? So, information classification addresses the impact or loss to the organization if the confidentiality, availability, integrity, authenticity, non-repudiation of their information is compromised, either by an insider or someone outside of the organization. All right. So it's but yeah, I like information management, but information management without classification is not gonna do it, right? So remember we talked about FIPS. In federal government, you complete FIPS 199 using the 800-60, which is the data taxonomy basically for the federal government. So the classification is always the first step. That's the critical step. All the rest doesn't matter if you don't do the classification. So,
Well, how does the characterization, how does that get involved in it? Categorization? How does that involve? Because in our earlier slides, that was supposed to be more like the impact of the information.
so couple days ago, I don't remember when, I pointed out when you see classification, it goes with data or information.
Oh,
When you see word categorization, it goes with the system or application. So you categorize your system as high, moderate, or low, but the data classification is there are multiple impact levels, right? So classification always goes with data. Categorization goes with system. And again, it's federal and my experience is based largely on federal government environment, and that's how it is. Now, in private companies, it may be different, and it may be challenging. If you come from private company environment, the terminology may be different. Yeah.
Okay, thanks.
Sure. So, in other words, try to remember classification is informational data. Categorization would be system or application. All right. Question 59. Mhm. Yeah, that's a difficult one, to be honest. I would probably get it wrong.
Delta.
So C would not be applicable, right? Because it says physically destroying storage media. No. So C, Charlie doesn't apply. D, marking, labeling, synonymous terms related to placement of relevant. So it says only physical. So D wouldn't be correct, right?
I would
Because
say A.
yeah, it's A. It's a good answer. A good choice. Yeah, A is correct. C,
Right, because
D,
isn't marking, as it was explained to me, marking is the how, right? But labeling is the what, right?
So in one of those, so actually in CSSOP, there's a whole section on the subject marking versus labeling, and the distinction in CSSOP context is whether it's a computer readable or if it's a human readable. So, but I don't know. Here so far I haven't seen anything to this effect in the instructor guide. So I read the entire instructor guide, every single page, and so far I haven't seen anything to the effect of distinguishing, marking, labeling. To be honest, I haven't seen it there. But the correct answer is A.
And I thought the reason why I thought it was A is because like labeling speaks about when you go to court and when you have to proper handling of data, everything needs to be labeled. So I kind of assumed that that was more external use in terms of what is it, handling, custody of handling that aligns with the label.
You're definitely smarter than me in that sense.
Oh, I had to put that together.
No, because to me, it doesn't make sense. To me, it doesn't. It's all semantics. Marking, labeling, it's all semantics to me, to be honest. But what you're saying makes sense. You're right. You're right. And thanks God, I haven't been to courts too much, actually. So maybe that's why. But you're right. That's what CISSP. That's exactly the rationale they give you. They say that marking is the external identification, like a physical, and labeling, it's a computer readable, so it's attributes of the internal data structures. That's what CISSP guide tells us. But
So
in this,
marking,
yeah, go
yeah.
ahead.
No, sorry, it's okay.
No, marking is something human readable, you can see it, and labeling is something that it would be application readable or computer readable. It wouldn't be obvious to you. So
Yeah. So for example, serial number is labeling
um,
product serial number, or because it's both. It seems like it's
I guess, yeah, I guess. To be honest, this is confusing to me, but I would imagine that labeling is if you right click on any file on your Windows laptop and you look at the properties, you will see supposedly the labeling, right?
yeah, yeah.
But then I don't know, to be honest, I don't want to fake it. I'm being honest with you guys. I'm not sure. This one is confusing to me, okay? I'm being honest. So question number 60. Network and system security is what type of asset? Hmm. Well, it's not firmware, that's for
A.
sure, right? It's not hardware, it's not firmware,
It's
right?
not.
And software is too generic, right? There's got to be information by exclusion. And I'm just going by exclusion because it's definitely not firmware, right? And it's not hardware. It's inclusive. Network and system security includes hardware, includes firmware, but it's not exclusive to that category. And it's not exclusive to software because there's software, there's hardware, there's firmware. So it's got to be information. So it's the correct answer is C, Charlie. All right. So question 61. How is a customer database categorized in terms of asset classification? So let's do the exclusions, right? So it's not firmware, definitely. Same as the question 60. It's not firmware. It's not hardware. It's not just software because it could be all of those, right? It would include typically database would include software, hardware, and firmware. So it cannot be one of those. So it's got to be C, Charlie. These types of questions, actually, you pray that you have more of these types of questions on the exam because you can work them out by exclusion. They're fairly easy, I think, in my opinion. So question number 62. intangible asset, right? So company vehicle, could it be intangible asset? I guess. Reminds me that German fairy tale, Andersen, about the king who wore invisible clothes, right? Yeah. So company vehicles got to be tangible. Office buildings got to be tangible. Manufacturing equipment's got to be tangible. So we have a consensus. That's B, beta.
Mhm.
Yeah, it's got to be B because the rest of them are very, very tangible. So,
What did you say was 61 for the database?
oh, so with 61, think about this.
I would pick
Database,
B, but I'm just wondering if they gave you the answer.
look, hardware. So it's the same as question 60, the same rationale. You cannot just limit it to hardware. You
Mhm.
cannot limit it to firmware. You cannot limit it to software. It's all of the above. See? And that's
Yeah, but if
why,
that's not an option,
well, that's information.
is
Same
there?
here.
Oh, I see what you're saying.
It's by exclusion, by exclusion.
Mhm.
You remember you need to pick up the best answer, not the perfect answer. There's no perfect
Oh.
answers. They do it on
So you're
purpose.
saying it's information.
Yeah.
Hmm.
I don't like it because in my head it's not information, but it's the
Oh,
best.
I see what you're doing because it says customer database. So it's data about them. Gotcha.
Right, right.
Mhm.
By exclusion, right?
Yeah.
Okay, question 63. Which of the following assets is not traditionally considered tangible? It's not tangible.
I would say software.
Exactly, yeah, because what else? I mean, all the rest is very tangible. So, okay. Question 64.
A.
Yeah, I agree.
Yeah, alpha is good, defining what an asset is. Yeah. Because if you don't define it, then kind of hard to do the rest. I hate this kind of questions. Whenever they say plan, do, act, whatever, oh my gosh, that's not my favorite type of questions.
I think this one was A also. Could have went over this.
What is the correct set of phases or activities in the
Yeah.
IT asset management life cycle phases?
Yeah, you're thinking of the information management lifecycle. This is the actual physical IT management, well, IT asset management. So I think it's D.
D is excellent choice, yes.
I agree.
Okay.
It's D, yeah. And again, I hate this kind of questions. So, I mean, to you, it's obvious. To me, it's, I don't know.
Although I can't remember the actual steps, right, until I see them in a multiple choice question. But
So it's plan, identify, align, decide to manage. Yeah, now it rings the bell, decide to
Oh,
manage. So once you identify, you decide to manage or not to manage, right? So we talked about that Wi-Fi enabled coffee maker in the lobby of a bank that my friends used to, they hacked it and they used it as ingress point to compromise the entire bank infrastructure. So a real story, real story. It was in Chantilly in Virginia. Okay, question
You,
56.
you guys were saying that the first one was going to be create, use, share, store, archive, destroy oceans. That one?
No. It's 65 is Delta.
I still I know, but the first one, they said it's something else.
yeah, that's the information lifecycle.
Information.
This is-
Okay.
Yeah.
Right. So And for me, the only part of this I remember decide to manage. That's what triggers in my mind. The other one,
Yeah,
distinguish. Then yeah,
that's what they were saying. Just find the trigger words to
Mhm.
remember them.
yeah, yeah. And so for me, it's decide to manage. I remember that.
Thank you.
Mhm.
Okay.
66. Who is responsible for the data content, context, and the associated business rules? Hmm. That's a
A,
huh?
A, alpha,
Delta?
alpha.
Alpha? No, no. And you remember, so on the exam, try to avoid anything with data owner because data owner under GDPR is not clearly, it's a very fluid concept. You remember we talked about this?
Yeah. Well, I'm thinking A or D, but I'll lean.
In perfect world, yes, but in GDPR world, no.
Custodian,
Yeah, no, will be steward.
steward.
Yeah, I'm thinking A or D, but
So steward is responsible for data content, context, and the associated business rules. Even though I don't like how they phrase because they use data content, but then again, if you think about collection, right? So they collect data. You remember I was telling you about the marketing. The idea is that in the past, the marketing was mostly physical. You go on the street and there are billboards and TV, you have those programs and marketing. And nowadays, it's so digital marketing, and mostly digital marketing. And Facebook, Google, and all those other companies that do digital marketing, they have to convince business stakeholders that they have this intelligence or secret recipe, or they know something about their users. And so they collect this data and they sell it, they massage it, they derive additional products from it. So data steward is the right answer. Okay, question 67. What action distinguishes the data processor role from the other data management roles? Yeah. Data processor role from other data management roles. So B definitely would not be correct answer because the value would not be determined by data processor. Responsibility for data content, context, and business rules. We already know that steward, right?
another
C.
A or
C. I would think C.
So it would be A or D, right? Accountability for protecting data while in custody.
Well, accountability for protecting data would be a data custodian's responsibility,
Right.
right? But processing the data based on proper controls, so data processor in reference to like the GPDR,
Yeah.
right?
Mhm.
And how it be processed. I think it's A, but yeah.
Well, according to the guide that I have, it says
Okay.
data processor processes data on behalf of the data controller.
Mhm.
And while they may be given the responsibility of protecting the data, accountability, so the keyword accountability remains with the controller. So I know it doesn't make sense. It's not the best question, how they phrased it. But yeah, that's,
So it is D, or
yeah, it's delta.
got it.
So I will read it again for you guys. A data processor processes data on behalf of the data controller. And while they may be given the responsibility of protecting the data, accountability remains with the controller. So that's the rationale that's given here.
Yeah, it just didn't make sense to me because it asks what action distinguishes the data processor role, but got it.
Yeah, it's a, you're too logical. Unfortunately, they are not. No, and I agree with you, and I agree with you. And some questions, people should be reporting them. And there's a errata forum, and people can report what they think is erroneous or not correct, because they're not like IC squared. They're humans. They can be making errors too, mistakes. So, in other words, yeah.
This is
So, question 68.
Hmm.
Uh-huh.
Yeah, would it be
6 major sets of activities applied for the data security life cycle.
B.
Which
Yeah,
of the
that's what I
following is not a step? Which is not a step? So
I thought.
B, beta
Yep.
assigning is not the step.
Yeah, B.
B is in boy or
Yeah.
dog?
No, B is in boy, yes.
Oh, okay. Okay.
And here's the reverse logic, right? It says not a step. Not a step. So creating, sharing, archiving. Yeah. Which actually makes sense, because if you think, well, there was this cycle, there was like that wheel kind of with those words. Yeah, I remember. Number 69. So primary purpose, creating plan. So plan for purging data in a data retention strategy. So plan for purging data. So safeguard it indefinitely. That doesn't sound right, right? To safeguard it indefinitely just doesn't sound right.
B.
It's actually D, delta.
Determine the course of action when the retention time expires.
To automate data retention. So A would not be correct, because without considering time constraints, that's definitely right away it screams at you it's not correct, right? So what's wrong with B? Let's see. To prioritize data security measures over retention policy. So that doesn't sound right, because you don't prioritize. It just doesn't sound right. Because,
Right.
yeah, the key word here is, yeah. All right, question 70, and we have 7 minutes left, so probably can do another couple of questions. All right. I hate those long questions. Okay, best aligns with proper data retention practices and regulatory compliance in the following scenarios. So, legal document person recently revised the data retention policy to. So which of these approaches best aligns with proper data retention practices and regulatory compliance? Okay. So when you see word all, retaining all client data indefinitely, that's immediately should tell you that's not a good option. Because all indefinitely, anything in using this kind of words, that's typically not the correct answer. So applying longest known retention period. So the word longest known retention period should tell you right away that's not correct, because you don't know if it's longest. Maybe you need to apply shortest. Depends on the regulations and so on, right? documenting record schedule that specifies the retention period for each type of information, ensuring all departments adhere to the schedule without exceeding these periods. That sounds the best so far, right? And again, deleting all clients' records after a single standard period, that doesn't sound right. So the best answer is C, and that's the correct answer. And I hope the rationale is clear to you.
Yeah, that was my first choice, and I changed it.
Yeah.
But it can be right sometimes when using all, or most of the time it won't be the right option. Like that we can eliminate it.
Well, look at A. All client data indefinitely.
Yeah.
That's I cannot think of any situation when you would retain all data indefinitely. It just doesn't sound right. That's, well, indefinitely is just not possible. So I mean, you don't know if you'll exist indefinitely. So applying the longest known retention period for all types of data, that's right away, it's obvious it's not correct. So yeah, I mean, this one is actually easy question. 70. So 71, question 71. Which of the following should be considered a source of data remnants? So do you remember what data remnants is?
I'm guessing C on this.
When data is deleted, supposedly, but it still somehow remains in the system, right? So with user interface, you think you deleted file, you clicked, you hit delete button, whatever, but actually it's still there. So all of the above could possibly be sources of data remnants. Potentially it could be in CPU registers and RAM, drives. Yeah.
I thought the RAM was like volatile. No.
Yeah, but you remember side channel attacks?
Oh yeah.
So that's a valid attack vector. Yeah. So in all of these cases, in solid state drive, remnants is not forever. Obviously, could be a short period of time. It could be just a couple of milliseconds, but it's enough in some cases for data to be compromised.
Oh, good point.
Yeah. So question 72. Which of these actions is most effective? Okay. All right. So again, data remnants, right? So updating antivirus probably wouldn't do anything, right, with regard to remnants. Implementing policy for frequent change of user passwords. It may be good policy, but it's not related to remnants, right? Using data wiping techniques that override the storage media multiple times. That's a good practice, right? You remember I told you Windows has a utility, free utility called Cipher, C-I-P-H-E-R, Cipher, and you can use it on your laptop to prevent data remnants. You can actually clear out those unallocated storage blocks. So restricting access to sensitive data based on user roles and privileges, which is a good practice, has nothing to do with data remnants. So C is the correct answer. So in other words, imagine you have super sensitive files on your laptop, and you deleted them by clicking delete, and then you emptied the recycling bin, and then just to make sure it's completely deleted, you can run the Cipher tool on your Windows laptop, and it will completely overwrite those blocks with zeros and ones with random stuff. So, and there are of course commercial grade tools that do the same. Yeah, but Cipher is a free utility that comes with Windows. Most of us, we don't really need to do that, right? Because I mean, I personally, I don't have any such files that I would want to hide or delete.
But data wiping in terms of that question is under clearing, right? It's a clearing technique, not a purging technique. Have I got that right? Because purging would be some sort of, God, what were they? Well, obviously degaussing, and then removing the encryption keys for cloud.
So when we discussed that, and I remember it clearly in the instructor guide, purging, clearing, and everything was part of one sentence, one long sentence. In other words, in my guide, there was no distinction between purging and clearing. But you're right, maybe in some cases it's a semantics. I don't know, purging, clearing. So in this case, data wiping implies that you're not destroying your media. You're only wiping, you writing zeros and ones into unallocated blocks, right? So that's the distinction. But I guess with degaussing, I mean, if you degauss your hard drive, then I don't think it's usable after that. I think it's done. So. Does it make sense? And again, words purging or wiping, I think in this case, just semantics. Either they could be used interchangeably, I think, in this case.
Yeah, I've got a destination CISSP guide, and they break it up between best and worst sanitization techniques. And then the best, obviously, is complete destruction, crypto shred, disintegrate, drill. That's all under destruction. And then degaussing is like on that boundary between destruction and purging. And then purging for them is degaussing, and then some sort of encryption. I can't read it; it's too small. But and then obviously in clearing, you have overwriting and then formatting, which is probably your worst, right? From best to worst, complete destruction to worst, overwriting blocks would be clearing. At least that's what it explained to me in this particular guide. So sorry if I'm muddying things up, but that's
no, it's cool. It's cool. I don't know if you're muddying or not, because so in the other course that I'm delivering, CISSP, it does mention those techniques, but there's no distinction. They don't distinguish them like the worst or the best or most reliable or the less reliable. They just describe these different use cases. That's it. But maybe on the exam, maybe it will be that way, you know. So if you look at question 73, that's the next question. So it's to your point, right? It's kind of which one is more reliable, right?
D would be the D then.
Which form of data destruction reduces the chances of recovery of data remnants? So the destruction would be I don't know. The correct answer is B, boy, purging. And the explanation is currently purging reduces the chances of the recovery of data remnants, but that might change the future improvements in forensic techniques. And so the question is, because the context is data remnants. So if you destroy a drive physically, is there data remnants? There's none.
No,
There's none. I think that's the logic here. Anyways, we are 5 minutes over time. As always, I enjoyed my time with you guys. Thank you for being with me. Have a great day. and we'll resume tomorrow.
Thank you, Alex.
Thank you.
All right.
See you then.
All
Thank you,
right.
Earl.
Thank you.
Have a nice day.
All right. Bye.